Hello there. Welcome to the Engineering Mechanics video lectures. In this video lectures, we are going to be talking about the composite area, the moment of inertia. The moment of inertia we are trying to determine for the composite area or maybe to the hollow section. So before going to this one, we need to define what is the composite area, right? So there we can see the definition. A composite area is made up of several components of areas, familiar geometrical shapes. So in this case, the composite area is made up of several component areas with the familiar shapes we are going to be talking. So for this one, I'm trying to take a geometrical shape. So there we can see, by looking itself, it is going to be a single object. But that's what I'm saying. This is going to be a composite area. So then what I'm going to do, I'm going to be made up of with the several components of the areas. So then I'm going to be trying to convert into the convenient areas here. So there we can see there is going to be different shapes are going to be. That means we need to develop the individual component areas with the familiar shapes. So there we can see here, I'm going to be taking over here. So can you see these objects will become the semicircular objects. So then from here I'm going to be taking here the imaginary line, so that it will divide it into here one triangle area as well as the composite, that means here rectangle area. There we can see the composite area is made up of several components of areas. Can you see how many component areas we do have? The three components areas we have. One is going to be your semicircle, and next one is going to be rectangle, the next one is going to be the triangle, and areas of the familiar geometric shapes here. So that I'm going to be saying the section 1, section 2 and the section 3. So I have made it the three sections of that. So then I can find out the area of the A1, A2, right, and A3. That means individual areas I am going to be evaluating A1, A2 and A3. And after that I am going to be taking the centroid of the each individual components. So that's going to be C1, C2 and C3. As we know that the area of A1 plus A2 plus A3, that is the addition of the individual areas, I am going to be getting the total area. At the same time, the total area consists of its own centroid. So that means the total area is going to be concentrated at one point. So that's going to be the C. These are the individual areas and it's a centroid. That means this area, it has its own centroid, that's going to be the C1. And similarly, the centroid, that is the second component, is going to be your C2. And here is going to be your C3. Right, and compared to all this one, there is going to be another centroid is going to be existed, that is the C. That is the common centroid for your composite area. Once I have calculated the A1, C1 and the total area on its centroid. So what I am going to do, I am going to be calculating the moment of inertia from the each centroid. Suppose the section 1 is going to be there. So that what I am going to do, I am going to be taking the I1, I am going to be taking. So that's the moment of inertia I am going to be calculating for individual components, that is the I1. Similarly, section 2 also, it has its own centroid and the moment of inertia I am going to be calculating here. So that's going to be I2. Can you see? And similarly, the third object also, it is in the rectangle shape. So sorry, it is in the triangle shape. So that I am going to be getting the I3. Can you see here? I1, I2, I3 are the moment of inertia of the individual components 1, 2 as well as the 3, which are passing to the centroid C1, C2 as well as the C3. So then what will happen? So once I am going to be calculated I1, I2, I3, so then I have to calculate with respect to the common centroid over here. So that means the total area is going to be concentrated at the point C. So then the same equations I am going to be, by applying the parallel axis theorem, I am going to be calculating for this. So that I am going to be taking I1 dash. I1 dash is going to be, which is passing to the common centroid, that is equal to I1 plus A into H square we are going to be taking. So that I am going to be taking H1 square. That means I am going to be measuring the distance between C as well as the C1. So the same thing I am going to be substituting here. And similarly, I am going to be taking the I2 dash. The I2 dash here is the parallel axis theorem. That's going to be your I2 plus A2 H2 square. Right? The distance between your C2 as well as the C. And similarly, I3 also I am going to be calculating. I3 dash is equal to I3 plus A3 H3 square I am going to be considering. In this way, we have individual centroids and individual moment of inertia I have calculated, and then I extended to the parallel axis theorem. That means with respect to the common centroid, I am going to be calculating the moment of inertia. Suppose the C1 is going to be there, and with respect to this axis and this area, how it is going to be distributing and how that area is going to be developing the resistance to the bending force, I am going to be calculating. That's going to be I1 dash, I2 dash as well as the I3 dash. Once if I am going to be calculating this one, then the addition of these three moment of inertias, we are going to be calling the total moment of inertia for the composite area. So here we are going to be taking the total moment of inertia I with respect to the C. I am going to be taking here. That's going to be your composite area. That's going to be I1 dash, I2 dash and I3 dash. Can you see the combination we are going to be taking? The individual moment of inertias and which are passing to the centroid, and the parallel axis theorem we are applying, which is passing through the common composite area, the centroid, and then we have calculated. So in this case, what will happen? We have started the addition. If suppose there is going to be wires are there may be a hole is there, or maybe the metal has removed. So then what will happen? We are going to be subtracting on this one. Suppose for this one, so here I am going to be taking the one example, one rectangle shape I have taken and one hollow here taken. So in this case, what will happen? The height of the rectangle is going to be the h, the base is going to be the b, and diameter of the hole is going to be the d, suppose. So in this case, what will happen? We are going to be calculating the total moment of inertia. In this case, I is equal to, so the section 1 and the section 2 I am going to be taking. Section 1 is going to be your rectangle area and the section 2 is going to be your circular area, which is going to be the hole. So then I am going to be taking from here is going to be I1 minus I2. So that means which material is not available within that area, that we are going to be subtracting. On that basis, we are going to be calculating the moment of inertia. So with this example, then I am going to be trying to take a few case studies and we are trying to draw the free body diagram so that we can going to be more familiar with this concept. So in continuation of that, I have taken a few regular shapes. Suppose this is going to be the T section we do have, and here is going to be the I section is going to be available. So in this case, what will happen? It's going to be a single object is there. As for the definition of this one, we need to make it convenient or the familiar geometrical shapes we have to prepare it. So there we can see here, and this is going to be the composition of, as for my point of view, it is the single one. But as for our mathematical analysis, we need to make it the two components. How? I'm going to be taking here the dotted lines here. I'm going to be consider this is the section 1 and this is the section 2. And I'm going to be taking this is the H1 and this is the H2 and this is the B1 and this is the B2. Can you see, by using these definitions, I can calculate the moment of inertia. That one, we need to find out the centroid and common centroid and then moment of inertia, and the parallel axis theorem we need to apply, and then we need to be calculate the same way. And similarly, in the section 2 we have taken, can you see here the case study, this is the I section. So I am going to be making the familiar geometrical shapes. So that I am going to be taking here. Can you see, this is going to be the section 1 and 2 and the 3, right? I am making for my own convenient, and you can take it in this direction also. Suppose I have taken the sections, 3 sections, or you can make the number of sections in this case. Suppose this way also we can consider here. So can you see here the dotted lines I have taken in this direction. So can you see section 1, section 2, section 3 and section 4 and section 5. Can you see, initially it is going to be only the 3 components are there, but now it will become the 5 components. So this way we are going to be making as per our convenient. I have taken another 2 more cases here. Can you see, I have taken a Z section over here. As for my knowledge point of view, I can make it the 3 sections here. So that means I am going to be considering over here the 2 dotteds, section 1, section 2 and section 3. So this way we are going to be make it, or we can make it in this direction also. So as per your convenient. Suppose this is going to be the C section. So then how could you take the composite individuals? So can you see here, I am going to be taking over here in this direction and this direction. This is the section 1, section 2 and section 3. So I hope you are going to be more familiar how to convert the composite area into the individual areas, and so that we can calculate the moment of inertias. Suppose there is going to be another section, already I told to you, there is going to be a circle is going to be there. Suppose in this circle there is a hollow is there. So then in this case what will happen? How we are going to be calculating in this case? So then I am going to be say this is the section 1, this is the section 2. The total moment of inertia is equal to I1 minus I2 I am going to be taking. So on that basis I can find out the moment of inertia. When there is a material is not available, or there is a hole or the way out, then automatically the subtraction we are going to be taking. I hope you are able to understand the concepts of the composite areas and the moment of inertia. So still you feel any difficulty, please put in the comment section so that I can reach out to you. For better understanding, so please watch the complete video so that the concepts will going to be built and you will better understanding is going to be getting into your mind. Okay, thank you.